All right, page 3, simplifying. So all of these when you're simplifying logarithms, you just have to put them in exponential form. So you're just setting them equal to x, and you're going to solve for x. So you're going to put them in exponential form. Square root of 3 raised to the x equals 27. And all of these, if they can be done without a calculator, which that means that they should be able to come out with the same base. So this one is a base of 3, so it's 3 to the 1/2 raised to the x. That would be 3 to the 1/2 x. This is 3 to the 3rd. So I just set those equal to each other. I get 1/2 x equals 3. Multiply both sides by 2, and I get x is 6. So just putting in exponential and knowing what the square root means, you have a fractional exponent, and 27 is 3 to the 3rd. Same with 16. Set that equal to x, and I have 5 to the x equals 1 over the cubed root of 25. So now we have a base of 5. We just have to figure out what base of 5 is this. So 25 is 5 squared, so we really have 1 over the cubed root of 5 squared. So I have 1 over 5 to the 2/3 power, but because it's in the denominator, that means it's negative 2/3. So I know 5 to the x equals 5 to the negative 2/3 power. It's the cubed root, that's where the 3 comes. It's 5 squared, but because it's in the denominator, it's negative 2. So x is going to equal negative 2/3. So we got a common base of 5. This one, e to the x equals the square root of e to the 5th. So again, this is square root, so it really means I have e to the 5/2 power. So x is going to be 5/2. So this is just really knowing your exponents well. This one says I have a base of pi, so it's pi raised to the x power equals 1. Anything raised to the 0 power will give me 1, so x is 0. So basically the log, no matter what the base is, the log of 1 will always be 0. Okay, and then we have the two that are exponential, so you do the same thing, set it equal to x, but now it's in exponential form, so you put it in log form. Log base 3 of x equals your exponent log base 3 of 5. So now I see that x has to equal 5. And I'm done. All right, this one's a little bit tougher because if you set it equal to x, you say log base 2 of x equals the log base 4 of 3. So now they're not the same base. And we always said, if you don't have the same base, you have to change a base. So this is log base 2 of x minus, well, equals, I'll do first, log of 3. I'm going to go log base 2 of 3 because this is a base of 2. So I'm going to say this is log base 2 of 3 divided by the log base 2 of 4. So remember, it can be any base. So I took the log base 2 of 3 or the log base 2 of 4. Log base 2 of 4, you're asking yourself 2 raised to what power gives you 4? So that's 2. So now we have log base 2 of x equals log base 2 of 3 over 2. I would probably get rid of that 2, so that becomes 2 log base 2 of x equals log base 2 of 3. The 2 can become x squared, so I'm really going to have the log of x squared, log base 2 of x squared equals log base 2 of 3. So that means those two things have to be equal. So x squared is going to have to equal 3. X is going to equal plus or minus square root of 3. And then we look to say, which of these do I have to eliminate, or are they both answers? So think about my original problem. It said I was taking 2 raised to some power. Well, when I have an exponential, I can't get an answer that's negative. So I know that that can't equal negative radical 3, so it can only equal positive radical 3. All right, so because that base was different, this one's a little bit tougher than this one over here, where this base and the log base are the same. Okay, and then 21, find the domain. Domain is, remember, when you're taking the log of something, you can't take the log of anything 0 or negative. So whatever you're taking the log of, doesn't matter the base, whatever you're taking the log of has to be greater than 0. That's it. That's all you have to do. And then solve that. X is greater than 6, x is greater than 3, x is greater than 1/2. That's how you find the domain of a logarithm. All right, now 22 is a little bit different because 22 is an exponential. So I'm looking for the domain. Remember, an exponential looks like, if it's a base of 3, is an increasing graph. Now the minus 6 is going to push it down 6, and the 5 is going to stretch it out a little bit. But really, if I'm asking for domain, the domain of that is all reals. I can plug any number in an exponential to solve it. I have no restrictions. I can put in positives, negatives, radicals, anything I can put there. So because that domain is all reals, or it's exponential, that domain is all reals. If I asked you the range, that would be a little bit different, because then you'd have to worry about, oh, it got pushed down 6 units, and know that to find the range. But we were just asking for the domain. 22, same thing, we're looking for the domain, so what we're taking the log of has to be greater than 0. Now this one's a little bit trickier because you have a squared, so we have x squared is greater than 4. So remember, now we got to think about, we can't just take the square root of that because we don't know if it's greater than, less than, what's going on there. So think about the graph. X squared looks like this. I want to know, when is x squared greater than 4? Well, here's y equals 4. So the greater than is going to be 2 pieces. You know, it's going to be when x is greater than 2. That's what you'd get when you took the square root of both sides. Or it's going to be when x is less than negative 2. So it's kind of like that when you take the square root of an equation, you got the plus or minus. Well, we have the plus or minus, but we got to think about what kind of a sign we're going to get here. So it's x is greater than 2, or on this side, it's x when x is less than negative 2. So that's a little review of solving quadratic inequalities. All right, and then this one, same thing. We're going to set what we're taking the log of greater than 0. And this is a review of what we did in a previous chapter of how do you find out where a fraction is greater than 0. Remember, we drew the number line and we said, where does the numerator equal 0? That happens when x is 3. Set this equal to 0. That happens when x is negative 1/2. And then you just have to do the pluses and the minuses. We're looking for the positives. So if I put in 4, 4 would be a negative up here. Here I get a positive, so a negative over a positive would be a negative. Something in between here would probably be 0. 0 would be a positive here and a positive there, so positive over a positive. Something down here like negative 5. 3 minus a negative 5 would be positive. 2 times negative 5 plus 1 would be negative, so I'd have a positive over a negative. And again, I'm looking for the greater than zeros. So I'm looking for everything here. It can't equal 0, so I can't include that. So it's everything, I'll use interval notation, everything between negative 1/2 and 3. Okay? So that's page 3. I think I'll just do another quick short video on page 4.